More stoichiometry problems. We are given an equation for a reaction between carbon monoxide and hydrogen gas that forms methanol. Let's balance this equation. There are 4 hydrogens on the product side. There's only 2 on the reactant side, so let's multiply that by 2. We don't write ones, but I'm going to put coefficients here just for visual purposes. On to part A. How many moles of each reactant? Oh boy. All right, and we're given the mass of the product. Let's start with what we know. We're given 3.60 times 10 to the 2 grams. Well, we would never. Yeah, let's just write this: 360 grams of CH3OH. And first step in Stoic is to convert to moles. So we're going to need the molar mass of methanol. We'll do that work off to the side here. Carbon and methanol has molar mass of 12.0. I'm just going to round these to 3 digits. And hydrogen, there's 4 of them. Each has a molar mass of 1.01. That's going to give us 4.04 for the hydrogen component. And oxygen is 16.0. So let's add them up. Oh, what is that? 28, 32. So it looks like it's 32.04, 32.0. Okay, so there is the molar mass for methanol. Don't forget to cancel out the units. That appears on the top and bottom. Now, step 2 is where we convert to the desired substance. We're going to need this twice because there's 2 reactants, carbon monoxide and hydrogen. So I'm just going to copy and paste what I just did. Okay. So let's see, what is the mole ratio? All right, so it's a 1-to-1 ratio between carbon monoxide. So we don't even need this step, but we will just to show our work. Cancel, cancel. And what do we ask for? How many moles? All right, we don't need the final step because we have moles right now of one of our reactants, carbon monoxide. Let's punch these numbers in. 360 divided by 32 equals 11.25. Let's get 3. How many sig figs did they give us? They give us 3 sig figs, so our answer is going to be 11.3. Moles of carbon monoxide. Now, it asks for each reactant, so the only difference here is a 2 mole to 1 ratio. We have 2 moles of hydrogen gas. Cancel, cancel. Just going to double up 11.3. Actually, don't use your rounded numbers. Use your stored number, which was 11.25 times 2 is going to be 22.5 moles. All right, so there's your answer to part A. On to part B. Calculate the number of grams of each reactant needed to produce Y. Who makes up these questions? Right. Time to get some practice here. Let's start with what's given. Start with 4 moles of methanol, and we're looking for grams this time. At least these compounds are kind of simple. What did it say? 4 moles. All right, let's start with 4.00 moles of methanol. All right, at least we don't have to do step 1. It's already given moles to us, so we just need to use the mole ratio. Let's turn, remember it was a 1-to-1 ratio, so cancel, cancel. And, oops. And then now we're asked for the mass of the reactant, so we are going to need molar mass of carbon monoxide. Do that off to the bottom here. Carbon has a molar mass of 12.01. Oxygen has a molar mass of 16.00. There's one of each of those, so that's going to be 28.01. All right, so we need moles of carbon monoxide on the bottom, and then 28.01 grams of carbon monoxide on the top. That way moles cancels out, we're left with grams. Punch these numbers in a calculator. 4 times 28 is 112. 3 sig figs is what we need anyway, so we don't need anything more than that. Grams carbon monoxide. All right, let's do the other one. 4.00 moles. I should have copied before I did all that work. Methanol. Now this mole ratio is a 2-to-1, if you recall. We need 2 moles of hydrogen gas to make 1 mole of methanol. Soup. Cancel. Cancel. Molar mass of hydrogen. There's 2 of them. Times 1.01. 2.02 grams per mole. That's our molar mass. Put it right there. Put moles on the bottom. Because it needs to cancel out the moles on the top. 2 times 2 times 4. What do you think? 16, but is that decimal going to make a difference? All right. 4 times 2 times 2.02. It did make a difference. 16.2. We need 3 significant figures. Grams of H2. There's the mass of the other reactant. All right, last one, part C. How many grams of hydrogen are necessary to react with? Okay. So we're just going from reactant to reactant. We're given moles. At least we're given moles. We don't have to do step 1. And we're asked for mass of the other reactant. So start with what you know, 2.85. We're already given moles, so we can go right to the mole to mole ratio. My computer's about to die. I think it was 2-to-1. Let's make sure. Yep, 2 H2s to 1 CO. Cancel top and bottom. Pretty sure it asks for grams. We had that earlier. 1 mole of H2 has a molar mass of 2.02 grams of H2. Cancel, cancel. Calculator time. 2.85 times 2 times 2.02, 11.5 grams of H2 is needed to react